On this 6.7 power stroke, P0335 means the PCM may be losing the crankshaft position signal. In plain terms, the module is expecting crankshaft speed and position information, and it can set this code when that signal is missing for a calibrated number of camshaft revolutions. The truck may be in derate, may have reduced power, and after the repair, it may still show a warning message until it has been driven long enough for the message to clear. The broad fault areas can include the CKP sensor circuit, the sensor itself, wiring damage, connector issues, the crankshaft sensor ring, or a synchronization concern. Treat this as a technician-level electrical diagnosis. Start with the basic system checks. Confirm P0335 is part of the actual fault picture. Make sure the battery is fully charged and the starting system is working correctly. And if regeneration occurs during testing, let it finish before continuing because it may bias values. With P0335 present, go straight into the crank signal check. Turn the ignition on, access the PCM data, monitor the RPM PID, and crank the engine. If RPM is greater than 150, this P0335 path still moves forward to the CKP circuit checks. If it is not greater than 150, it also moves forward to the same circuit checks. One key clue for this code is that 0 RPM while cranking indicates a CKP concern. There is also a shared SYNC PID check in this diagnostic path. If you are not on the confirmed P0335 branch, and the earlier RPM check sends you there, access the PCM, monitor the SYNC PID, and reproduce the condition while watching that PID. If the SYNC PID changes from yes to no, continue into the CKP circuit checks. If it does not change from yes to no, do not force the P0335 circuit path. Go back to a symptom-based diagnostic direction. Next, turn the ignition off and disconnect the CKP sensor connector. Turn the ignition back on and measure voltage between CKP sensor C1120 pin 1 and CKP sensor C1120 pin 2. If the reading is between 4.5 volts to 5.5 volts, continue to the CKP signal circuit open check. If it's not between 4.5 volts to 5.5 volts, stop this path and diagnose that voltage circuit before going farther. Turn the ignition off and disconnect the PCM-E connector. Measure resistance between CKP sensor C1120 pin 3 and PCM C1232E pin 99. If resistance is less than 5 ohms, keep moving down the circuit checks. If it is not less than 5 ohms, repair the open circuit, clear the PCM DTCs, and repeat the self-test. Now, check for a short to ground. The confirmed test information includes a resistance check involving CKP sensor C1120 pin 3, and a confirmed check between C1120 pin 3 and C1120 pin 2. The exact endpoint for the first resistance measurement is not confirmed, so do not guess at that lead placement. Pause, recheck the earlier diagnostic path, and confirm the correct test points before making a pass or fail call. Once the measurements are performed correctly, the required result is greater than 10K ohms. If the resistances are not greater than 10K ohms, repair the short circuit, clear the PCM DTCs, and repeat the self-test. If they are greater than 10K ohms, move to the short to voltage check. For the short to voltage check, turn the ignition on and measure voltage from CKP sensor C1120 pin 3 using the correct second lead point. That second lead point is not confirmed either, so confirm it before testing. If any voltage is present, repair the short circuit, clear the PCM DTCs, and repeat the self-test. If no voltage is present, continue to the intermittent harness inspection. With the ignition off, reconnect the CKP sensor connector and the PCM-E connector. Then inspect the CKP and CMP11 wiring for chafing or physical damage. Harness damage in these circuits may cause an intermittent short, so do not skip the visual inspection. If you find a concern, repair it as necessary, clear the PCM DTCs, and repeat the self-test. If the harness inspection does not show a concern, continue to the CKP sensor physical check. Check the CKP sensor itself for damage. If the sensor is damaged, install a new crankshaft position sensor, run the crankshaft position sensor reset and clear function with the scan tool. Clear the PCM DTCs and repeat the self-test. If the sensor is not damaged, Check the ignition pulse crankshaft sensor ring for damage. If that ring is damaged, install a new ignition pulse crankshaft sensor ring. If the ring is not damaged, continue to the synchronization check. For the final check in this path, access the PCM and monitor the sync PID while cranking. If available, use an XY plot view so a state change is easier to catch. If the sync PID reads yes, the next diagnostic direction is different than if it does not read yes, so do not guess from here. Follow the appropriate next path based on the sync result. After any circuit or component repair, clear the PCM DTCs, repeat the self-test, and confirm P0335 stays gone. If a system warning message remains after the repair, drive the vehicle until the message clears from the IPC message center. The takeaway is simple. Prove the crank signal, prove the circuit, inspect the harness and hardware, then verify the repair. For more diagnostic training, visit stepdiagnostics.com.